You know, we throw around the term big data all the time, but what happens when that data isn't just big? What if it's deep? I'm talking about things like climate simulations or mapping the entire human genome. You're not just dealing with massive spreadsheets anymore. You're navigating these complex, multi-dimensional worlds of information. So how on earth do scientists even begin to manage all that? Well, that's where something called SciDB comes in.
So for this deep dive, we're leaning on some fantastic work from a show called DatabaseHistory, and they frame their mission with this line right here. It's perfect. Today, we're going to roll up our sleeves and really explore one of those engines, a database built from the ground up for the totally unique challenges of scientific research.
All right, so here's our game plan. First, we'll get a handle on the huge problem that scientists were up against. Then, we'll introduce the solution, SciDB, and pop the hood to see how it actually ticks. After that, we'll check out where it's making a real impact, see how it stacks up against other tools out there, and finally, kind of gaze into the crystal ball to see what kind of future it's helping to build.
Okay, let's get right to the heart of the issue. Why can't you just use a standard, off-the-shelf database for something like mapping brain activity or modeling global weather patterns? I mean, they're powerful, right? Well, the short answer is they just weren't built for that kind of job.
And this right here, this is the whole nut. Traditional databases think in tables, neat and tidy rows and columns. But scientific data, it almost never looks like that. Think about a climate model for a second. You've got latitude, longitude, altitude, time, temperature, pressure. That's not a flat table, that's a cube of data, maybe even a hypercube. And that fundamental mismatch is the exact problem SciDB was created to solve.
So what's the answer then? Well, instead of trying to force that multidimensional data into a two-dimensional box, the creators of SciDB said, let's build a database from scratch that speaks its native language. And that language is the array.
And listen, this isn't some side project cooked up in a garage. SciDB has some serious pedigree. It was founded way back in 2008, and it grew out of this powerhouse collaboration between heavy hitters like MIT and the National Institutes of Health, with guidance from some of the pioneers of the database world. From day one, the goal was crystal clear: build a ridiculously high-performance tool for serious, no-kidding-around science.
Okay, so we know why it exists, but how does it actually pull this off? This is where you see this fundamental brain-bending shift in how you think about data. The whole concept revolves around the array. Now, inside SciDB, an array isn't just a container for data. It's what's called a first-class citizen. What that really means is that the entire database is built and optimized to handle these multidimensional objects as single whole things. So you're not breaking that cube of climate data into thousands of little rows anymore. You get to work with the cube itself.
And this visual just nails the difference. Over on the left, you've got the world of tables, the home turf of databases like PostgreSQL. It's great, but it's organized around rows. Then on the right, you've got SciDB's world. It thinks in shapes, in volumes, in matrices. This really shows you just how big of a paradigm shift we're talking about.
Now, to actually work with these arrays, SciDB gives you some very specialized tools. It has its own query languages, equal and AFL, that are designed for doing complex math on arrays. And here's something crucial. It's ACID compliant. Just think of that as an ironclad guarantee. Every operation you do either completes perfectly or it doesn't happen at all. This ensures your data is always consistent and reliable, which for science is absolutely non-negotiable. And of course, it's parallelized, which just means it can chop up huge calculations and spread them across lots of processors to get you answers fast.
Okay, so we've got this powerful array-native engine. It's cool technology. But where is it actually being put to work? Where does all this tech translate into real, tangible scientific progress?
The applications are pretty much exactly where you'd expect to see a tool like this. In genomics, you're not just looking for one gene anymore. You're trying to see how millions of genetic markers interact across an entire population. In climate science, it's about making sense of petabytes of simulation data to build better models of our future. What's so amazing is that in every single one of these fields, it allows scientists to ask questions on a scale that was just impossible before.
Now, of course, SciDB isn't the only game in town. So it's worth asking, how does it actually compare to other technologies you might have heard of in this space?
This table gives us a really nice, clean snapshot. So, compared to another array database like TileDB, SciDB is considered more query-centric. It's really fine-tuned for asking super complex questions of the data. Compared to HDF5, which is a common file format in science, SciDB is a full-blown transactional database. There's that ACD guarantee again. It's about data integrity. And well, we've covered this one, but Compared to a relational giant like PostgreSQL, the difference is night and day. It's all about arrays, not rows.
So what's the big picture here? Where is this all heading? Let's kind of wrap this all up and look at SciDB's ongoing role in the world of research.
One of the really smart things about SciDB is its dual nature. It has an open source foundation, which means it's accessible to the whole academic community. But it's also commercially supported by a company called Paradigm 4, which makes sure its development is solid and well-funded. That combination, plus its intense focus on scientific rigor, makes it a tool researchers really trust. And that last point is maybe the most important of all. It's built for reproducibility, which is the absolute bedrock of the scientific method.
And that kind of brings us to our final thought. Tools like SciDB, they aren't just about managing data better. They're about enabling entirely new questions to even be asked in the first place. As our ability to collect data just explodes, the real challenge, the real frontier, is our ability to make sense of it all. Which leaves us with a pretty big question. What is the next great scientific mystery that a tool like this is finally going to help us unlock?